Hi guys, Mrs. Rona here. We are going to go through some notes on forces and free body diagrams. So if you could go ahead and turn your packet to page 4, that would be awesome. So page 4, we're at the very top, and as always, you can pause this video if you want, if you need to fill in some blanks or anything, but otherwise you can follow along. So target 1 for this unit is drawing free body diagrams. So first of all, what is a free body diagram? You'll see us call it FBD a lot, but free body diagrams are used to show the relative magnitude, which just means how much, and direction, so which way, of all the forces acting on an object, and we draw them using those arrows. So we've done these before, but we're going to kind of really lay out the rules for drawing these. So you fill that in the top of page 4. Now we're going down below that, some of the types of forces. So just a reminder. We have applied force, which is a push or a pull. That's kind of our catch-all. We can call anything really an applied force. Normal force, so normal force is that support force exerted when something's in contact with something else, like the ground or a wall. So if a book is sitting on the table, there's a normal force straight up. Friction force, so friction goes opposite the direction of the intended motion. So if something wants to slide to the right, friction goes to the left. And then we have gravitational force, which is weight. So in this unit, that's between the earth and the object, and since the earth's always below us, it's going to pull the object down. All right, we've got some rules. So now bottom of page 4, rules for drawing free body diagrams. First, you draw your object as a box, rule number 1. Number 2, if the object's touching a surface, draw on the surface using a dashed line. Rule number 3, all the forces go away from the object. So they're acting on the object using arrows, and they go away from the box. So you should never have arrows going in. They're always going away from your object. Draw your first force vectors or arrows proportional to the size of the force. Use on-by notation. We're actually not going to do that. So that's not in your packet. You can cross that off. You don't have to. And indicate which forces are equal using congruency tick marks, so marking which ones are equal. So let's jump in and try some of this. So we're going to go to page 7. So flip your packet to page 7, and here's our scenario. We're going to split it into A, B, C, D. So a car is initially stopped at a red light. The light turns green and the car speeds up, moving forward. The car reaches the speed limit of 30 miles per hour and maintains a constant velocity. And the car sees a stop sign ahead, applies the brakes, and comes to a stop. So we will do free body diagrams for all of these separately. So page 7 is just this first one. So a car is initially stopped at a red light. Let's go ahead, and I want you to attempt the free body diagram. So pause this video and just come up with what forces do you think are acting on the car while it is initially stopped at a red light. Go ahead and try that. Pause me now. All right, so hopefully you tried this. Now we're going to go through it together. So here's what you should have for stopped at a red light. So first, we've got FG pulling down, that's the weight of the car, and the normal force pulling up or pushing up, that's from the surface. Also, we have this line here, you probably drew it as a dotted line, that represents the surface the car is on. The velocity is 0, the acceleration is 0, and the net force is 0. And so the other thing you see at the top, it says, circle the words in the statement that lead you to believe if the net force is balanced or unbalanced. So we said the net force was 0. That's what this means. Sum of the forces is 0. And that's because the car is stopped. So you should have circled stopped. You should have zeros here, and you should have this diagram. These are going to be graded on the quizzes out of 6 points, and this is kind of the rubric. So go through and grade your first attempt and see how you did. So pause me real quick and grade your first attempt, maybe adding in any notes to yourself. All right, now we're going to do 1B. So flip over to page 8. So we're going to skip the bottom of page 7. We're flipping over to page 8. If I'm going too fast, you can always pause the video. I just want to make sure we get this all in here, okay? So page 8, the light turns green and the car speeds up, moving forward. So go ahead and first circle any statements up here that make you think the forces are balanced or unbalanced. Then draw your free body diagram list the direction of the velocity, the acceleration, and then the net force. So these can be arrows, so right, left, up, down, that kind of thing. So pause me real quick and try this on your own. Go. All right, hopefully you tried that. Now in the second box where it says second attempt, here's what we're going to put on there. So circling, you should have circled speeds up. That's important. That tells us the forces are not balanced. Anytime your velocity is changing, your forces are not balanced. We learned that in Unit 1. Here are the forces you should have. We still have gravity and normal force, and those should still be equal because we're not accelerating up or down. In the right and left direction, we have an applied force going forward, and we have friction resisting. You might have forgotten friction, but a car certainly has friction acting on it, right? Now these two should not be balanced. The applied force should be drawn as a bigger arrow than the friction. Also make sure you have the surface drawn in there, so the ground. The velocity would be to the right. Acceleration matches that because we're speeding up. So thinking back to our motion diagrams, anytime you're speeding up, your acceleration and velocity go the same direction. And our net force is also to the right. How do I know that? Well, I look at this diagram and I see that the applied force is bigger than friction. So we have an extra amount of force going to the right. So that's what we're going to do for that one. Here's our rubric again, so you can go through and see how you did. First, half a point for did you circle the right words? Half a point for the right force is going to the left, so that would be friction. Half a point for the applied force to the right. 1 point for drawing forces to scale. So is the applied force bigger than friction? Y direction, half a point for normal, half a point for gravity, and you get 1 point for marking those as equal. And then half a point for each of these arrows. So right, right, and right. All right, we're going to skip the bottom of page 8. Now we're going to page 9, free body diagrams. So now the car reaches a speed limit of 30 miles per hour and maintains that constant velocity. So first circle up here what tells you if the forces are balanced or unbalanced, and then try your free body diagram. Go ahead and pause me again. All right, let's see how you did. So you should have circled constant velocity. Don't forget, constant velocity, even though you're moving, means the net force is 0, okay? Acceleration 0, we're not speeding up, we're not slowing down. We have a constant speed, and the velocity is to the right, okay? We learned that Unit 1, and it's still a really hard concept, but if you're moving at a constant velocity, the forces are balanced. So then for our picture, we have gravity and normal force still equal, and then we have an applied force to the right and friction to the left. However, now they're equal. This picture is what causes constant velocity motion. These all four don't have to be equal. You could have marked like these with like 2 tick marks, but the right and left have to be balanced and the up and down have to be balanced. So go ahead and make sure you check through this rubric. You can pause and look through that. See if you understand how it's going to be graded. Let's try another one. Page 10, 1D. So now the car sees a stop sign ahead, applies its brakes, and comes to a stop. So we're on page 10. So first, circle the words above that tell you if the forces are balanced or unbalanced, and then try the free body diagram. So pause real quick, and let's see how you did. So circling. You should have circled coming to a stop, okay? That means slowing down. If you circled like applies brakes and comes to a stop, that's totally fine, but it's coming to a stop. So on page 10, that second box, this is what you want to draw in there. This is the right answer. So we have gravity and normal force. Those are still equal. There's no longer an applied force. If you're stepping on your brakes, your car is not pushing forward at all. The only thing happening is friction slowing your car down. By locking your brakes, so if you slam on the brakes, you can make the friction happen faster. If you do it slowly, you can kind of ease into that friction, but the only force is friction, and it's going opposite the direction of motion. So let's talk about the directions. Velocity still to the right. Looking at this picture, it's hard to tell, but this car is moving to the right. How do we know? Because friction's going to the left. Acceleration must be opposite of velocity. If we're slowing down, these two are working against each other. So acceleration's to the left. And looking at my picture, the net force, where is there force left over? What's going to win? This force going to the left, this force of friction. So this is probably one of the tougher ones. So make sure you've got this down. read through the rubric, and it makes sense. We're going to do some more examples. All right, on to page 11. So we're going to do another scenario. Scenario 2 is a figure skater. So scenario A is the figure skater is standing in the middle of the ice rink, not doing anything. Scenario B, she pushes off the ice and speeds up backwards. And then C, after pushing off, she glides backwards. Glides, I would say maybe is a constant velocity across the ice. So top of page 11, go ahead and pause the video, circle a statement up here, and try your free body diagram. So pause now. All right, let's go over this. So what you should have circled, standing, okay? She's not moving, so standing still. She has gravity and normal force because she's still on a surface, right? So don't forget that normal force. And then these things, 0 velocity, 0 acceleration, and the net force is 0. All the forces are balanced on her. So draw that in as your second attempt. Once you're done with that, we'll go to page 12. All right, 2B, the figure skater pushes off the ice and speeds up backwards, okay? So go ahead and pause this. First, circle something up here that tells you what's happening to the net force, if it's balanced or unbalanced, and then do the first attempt box. Go ahead and pause now. All right, going over this, what you should have circled, speeds up, going backwards, okay? Speeds up tells us that the velocity is changing, and so that means the forces are unbalanced. In terms of the diagram, we've got Fg down, Fn up, and applied force pushing her backward. So backwards we're going to call left. If you want to call it right, that's fine. Let's just, for simplicity's sake, so we're all on the same page, call backwards left. So she has an applied force pushing her backward. It would be the ice, right? She's pushing off. And there's no friction on ice. If you didn't know that before, that's fine. But ice, we're going to say, is frictionless. So there's no friction. In terms of these directions, velocity is left because that's backwards. She's speeding up in that direction, so acceleration has to match that. And looking at your picture, you see the net force has to be to the left as well. All right, let's try 2C. After pushing off, the figure skater glides backwards across the ice. And I kind of gave you a hint earlier. We're going to say glides is constant velocity. So go ahead and pause the video, circle a statement, fill in this first attempt box on page 13. Pause now. All right, going over page 13. So what you should have is glides, okay? Glides is going to be our key word there. It tells us that you're moving at a constant velocity. So the net force is 0. The forces must be balanced. This is another crazy free body diagram. So we've got normal force up, gravity down, so we should label this as Fg. She's moving to the left, but she has no acceleration because she's not speeding up, not slowing down. And the forces must be balanced. So there's nothing pushing her anymore. She's just gliding. So the ice is not pushing her. She's not pushing herself off anything. Okay, so there's nothing pushing her to the left. There's no friction. So these are the only forces acting on her. And this is another tough one. So make sure, again, you're looking through the rubric, you're writing this in your second attempt, and you're understanding kind of what we need to know here for free body diagrams. All right, guys, that's the end of the video. Thanks for watching. If you need to go back again, feel free to do so. Bye.